Hi, this is Mr. Merrill, and in this video we're going to talk about how to take components and change them into magnitude and direction. So basically switching from one way to mathematically write a vector to another. So say you're given this set of components for random vector A. How would you start this out? Well, the first thing I would do is sketch the components. So you're told that 7.632 meters and negative 39.265 meters are the x and y components of A. Remember that this notation means the same as what's written in the top left here. Essentially that the vector A is the sum or the resultant of adding the components AX and AY. So how do we know what these look like? Well, this tells us how much left or right, this tells us how much up or down. We follow this with this, and we get to sketch quickly what our components look like. So if this is the components of the vector A, then the vector A is just the resultant of those two components being added together. So now that we have that, we can begin to think of this in terms of a right triangle. So the first thing I want to do is find the magnitude. So the magnitude is essentially the length of the vector itself. So if we're told the length of the components AX and AY, which we have here, then we can think in terms of Pythagorean theorem to find the magnitude of the vector itself. And that's what I've done here, and that's an approximate answer, but it's approximately 40 meters. So we're using Pythagorean theorem to find the magnitude from the components. The only other thing we need to do is indicate the direction. So that's what I'm going to do right here. Is I can go back to that right triangle that I thought of and say, okay, well, what's this angle here? This angle here can be related to the components by inverse tangent, noting that the y component is the opposite and the x component is the adjacent side. So plugging in the lengths of those components, inverse tangent tells me that angle is 79 degrees. But that's just a random angle. What we really are interested in the counterclockwise angle. So what is that going to look like? Okay, so once you've found that interior angle is 79 degrees, you need to begin to think about the counterclockwise angle. So the counterclockwise angle, again, is starting out at the positive x-axis and rotating counterclockwise in the opposite direction a clock goes until you hit the vector. So what I have in this blue semicircle is the counterclockwise angle. So how do you go about finding that? You have to, again, think about in terms of the more familiar 90, 180, 270, 360 type things. It's not going to be the same thing every time, but you can think of a relationship such as the one I showed here. I know that this angle in the blue plus that 79 degrees has to equal 360 degrees. So with a little bit of algebra, I can find that the actual counterclockwise angle is 281. So again, what do? We started out with these components. We used Pythagorean theorem to find the magnitude of the vector A, and then finally we used an inverse tangent and a little bit of thinking about our known angles to find the counterclockwise angle. So essentially we started out with this way of writing a vector, and we ended up with the magnitude and the angle, the only other way you can mathematically represent a vector. Okay, so hopefully that helped.